Consider this experiment, which uses marbles and ping pong balls to represent different soil textures. Notice that not only are the sizes of the particles different, so are the gaps between them. In soils, these are referred to as pores, and the combined volume of all the pores is known as pore space. Notice as we pour water into both containers that it moves more quickly through the larger pores compared to the smaller ones. This is true in nature too. Generally speaking, the larger the particles of a soil, the larger its pores, and the more quickly water will move through it. This experiment uses perfect spheres and identically sized pieces. But in real life, soil particles come in many different shapes and sizes. Clays, for example, are often plate-like and have a tendency to stack together, which makes it hard for water to move. Compare this to loam soils, which, being a mixture of different soil textures, have both large and small pores. This means that water can move quickly through some pores and more slowly through others, making the soil well drained, but also able to retain some of that moisture for plant use. When it comes to soil moisture in agriculture, soil texture isn't the only thing to consider. Climate has a big influence too. In the summer, we get most of our precipitation from pop-up thunderstorms that build during the day and release their energy in the late afternoon or early evening. Most places will see rain a few times in a week, and the amount of rain from any given thunderstorm can vary widely, from just a trace to over an inch. The rest of the time, the weather is typically sunny, hot, and humid. During those periods, water will be evaporated from the soil, drawn up by plant roots, and may continue to move downward as gravity acts on it. How effectively a soil is able to hold on to water between summer rainstorms has implications for crop health and management decisions, such as if and when to irrigate. Add to this, when it does rain, how that rain falls and the underlying physical structure of the soil can also impact how much water enters the soil. Take, for instance, a heavy downpour. A lot of water enters the soil very quickly, and this can result in the upper layers becoming completely saturated before water is able to penetrate deeper. When this happens, additional precipitation will run off the surface instead of entering the soil. In contrast, during a lighter precipitation event, such as a slow soaking rain, water is able to slowly enter the soil and infiltrate those deeper layers. In our last video, we also discussed the different layers of a soil. If any of these layers become compacted, a layer of nearly impenetrable soil will form. This effectively creates a shallow layer of soil in which plants can grow. When it rains, this layer will become saturated more quickly, leading to more runoff. In the next video in this series, we'll learn about how the State Climate Office of North Carolina measures soil moisture.